Hello students, welcome back into the another session of CS07 data structure using programming in C. As all of you know that we are discussing about the concept of unit number 3, that is introduction to data structure and elementary data structure, where into the part of elementary data structure we have completed with the first concept of elementary data structure, that is called a stack, with their operation called push, pop, peep and update. Now it's time to go for the another type of the discussion of topic, that is called as Q. As far as the syllabus is concerned, we have to discuss three types of queue, that is a simple queue, a circular queue and the double-ended queue. The selected portion is the portion of a simple queue. So first, initially we'll discuss about the simple type of queue, then we go for the circular type of queue, and then we go for the advanced type of queue, that is called as double-ended queue. So I think right now is not the perfect time to go for the theoretical discussion of circular queue and double-ended queue. As the topic comes, we will discuss more about this circular queue and double-ended queue. But as far as the examination is concerned, simple queue and circular queue is most important, and second priority we can give for the double-ended queue. So let's start without wasting more time the concept called queue. Now as you can see into the concept of simple queue, we have to discuss certain type of topic like introduction, array implementation of queue, function to insert elements into the queue and a function to delete elements from the queue. That means these are the operation of queue. So let's first start with the introduction of queue, that means the definition of queue. So as far as the definition is concerned, queue is a circular kind of collection in which the entries in the collection are kept in order, and the principal operation on the collections are addition to the entities to rear terminal position and removal of the entries from the front terminal position. This makes the queue works in a model called first in first out. In first in first out data structure, the first element added into the queue will be the element to get executed. This is the equivalent to the requirement that once the element is added, all elements that are added before have to be removed while the queue has been invoked. Let's make this particular definition easy. So first of all, that we have to keep in our mind related to the queue is queue works on the data structure, or we can say the queue is a elementary data structure which works on the model called first in first out. Over here we can take the difference between the stack and queue also. Whenever we have discussed about the stack, at that time we have discussed that stack is a elementary data structure which works on the last in first out. So this is the first difference between stack and queue. Again I am repeating the difference between these two. Stack works on last in first out, while queue works on first in first out. Let's take a general example. The general example of queue is the queue which we found at cinema over the ticket booking counter. Again I am repeating my words. The simple general example of queue is whenever we are standing in a queue of collecting the tickets at cinema hall, or we can say at the bus station or the railway station for collecting our tickets. Say for example, the ticket counter is closed and one by one the person comes to collect their tickets. They stand in a one queue where the first person who comes at the ticket window will get the first ticket, then and then the second person will get the ticket, then and then third person will get the ticket, and so on. Whenever, say for example, this is the ticket window, and in front of the ticket window person number 1 is standing, then person number 2 is standing, then person number 3 is standing. Whenever the person number 4 comes, he or she have to stand after person number 3 only. And whenever the person number 5 comes, he or she have to stand after the person number 4. Now whenever this ticket window gets open, the ticket will be dispatched to the person number 1 first, then and then person number 2 will get the ticket, then and then person number 3 will get the ticket, then and then person number 4 will get the ticket, and then person number 5 will get the ticket. So this is the general scenario of a simple queue, or we can say the queue. Now over here what we have to technically develop, over here we have to technically develop that whenever the ticket window is closed and one by one persons are coming for collecting the tickets, person number 1 stands and wait for the ticket counter to get open. That operation is called as insert. So we can say that in queue, two operation we have to face, that is an operation of insert and operation of delete. That means whenever the person number 1 comes and he stands and wait for the ticket counter to get open, that operation is called as insert. Then person 2 will come and wait, that is called as insert. Person 3 came and wait, that is called as insert. Now once the ticket counter gets open, the first ticket that assigned to the person is called as person number 1. That means ticket has been collected by person number 1 and he or she goes out of the queue. Then person number 2 will get the ticket and goes out of the queue, and then person number 3 will get the ticket and goes out of the queue. That operation is called as operation of delete. So these two operations we have to follow. Now this is just a simple general example. Now for handling this such type of operation in a queue, one component will work. So this might be the second difference between stack and queue. In stack, the operations are push, pop, pip and update, while in queue operations are only two, that is insert and delete. So this is the difference number 2. Difference number 1 I have already conveyed to all the students. This is difference number 2. What is the difference number 3? To handle all this operation in stack, the component work is called as top of the stack, that is called as TOS. This is difference number 2. While in queue, the operation which has been handled by the component is called as front, and the second component is called as rear. So in queue, two component will handle the two operation, that is called as an operation of insert and the operation of delete, and these two components are front and rear. Now let's go ahead. Whenever user wish to perform the insert operation, they have to use front component. Remember this. Whenever user want to perform the insert operation, they have to go for front, and whenever the user performs the delete operation, they have to use rear. So one thing is clear, whenever the insertion operation done, we have to keep in our mind, we have to work with front, and whenever we are performing the delete operation, we have to work with rear. Again, the fourth difference between the stack and queue is, whenever we perform the push operation, this top of the stack will be increased by 1, if you remember that. Whenever we perform the pop operation, this top of the stack will be decreased by 1. So same like that, whenever we wish to insert any element into the queue, we have to increase front by 1, and whenever we want to delete any element, we have to increase rear by 1. So this is the difference. The difference is over here. In pop, top of the stack decrease, and in push, top of the stack increase, while in queue, two components are there for the two different operations. So whenever we increase front by 1, it performs the operation of insert. Whenever we increase rear by 1, it performs the operation of delete. So I hope all of you are very much clear with these two operations that we have to perform logically while we are implementing the program for the same. So I think we have to revise all these things again. What is Q? Q is a one type of elementary data structure which works in a circular kind of collection, where it follows the model called first in first out. That means first come first serve, even we can say like this. Q contains two basic operations. That two operations are the operation of insert as well as the operation of delete. To perform the operation of insert and delete, we have to keep in our mind the two components which is called as front and rear. Whenever we wish to perform the operation of whenever we want to perform the operation of insert, we have to increase the value of front by 1, and whenever we wish to delete the value from the queue, we have to increase the value of rear by 1. We can see the same thing by one pictorial representation which you can see onto the screen. This is a pictorial representation of a one queue. Over here there is a ticket counter where my mouse cursor is there. This is person number 1, person number 2, person number 3, person number 4. If person number 5 is coming, he have to wait after the person number 4, or we can say he have to stand before the person number 4. Whenever this ticket counter gets open, the first person will get the ticket, then second person will came across and he will get the tickets, then person number 3, then person number 4, then person number 5, and so on. Now whenever we are performing the same operation called insert and delete, there might be an option of exception handling. This is the difference number 5 between the stack and queue. If you remember, even we have handled the exception into the stack. Into the stack there are two exceptions, that is stack overflow and stack underflow. When we got the stack overflow exception, these two is totally depend on the size which you have defined for the stack. Say for example, I have defined the size of stack as a 5. So maximum 5 element I can push. After inserting the 5 elements, suppose I wish to insert another element, ultimately it shows the error message that is called a stack overflow. And reverse, I have already inserted 5 elements and then I have started deleting the elements. All the elements get deleted and still I want to delete an element from the stack, it shows underflow. So in Q, same type of exception we have to keep logically in our program, that is Q overflow and Q underflow. So again it depends on the size which has been defined by the programmer. That means suppose programmer has defined the size of queue as a 5, so maximum 5% can stand in a queue for getting collection of the ticket. And once the queue is full, once the cinema hall is full and deletion gets started and still the ticket, if user wants to assign the ticket to the particular person, it shows the queue underflow. That means queue is empty. Now there is no one for getting the ticket in a queue. So this exception we have to handle practically while designing the program for the same. Now algorithm for the same should be like this. Step number 1, that is the initialization of Q where we have to initialize some variables by setting it into the front position. So here I am initializing total 3 variable, that is front equals to 0, rear is equals to I minus 1 and one more variable, that is n, that is to be called as natural number. Now once this is done, step number 2 is what? Step number 2, repeat step number 3 while I is less than equals to n. That means it starts from the 0th position till it repeats I up to the last position of the assigned number. During this repetition, it checks the condition for Q is overflow. That means if all the elements get fitted into the queue and there is no space to assign the new value into the queue, it shows Q is overflow. If this thing is false, then step number 3 will increase the value of front by 1, that is front plus plus, and on the desired location of the stack, location of the queue, it stores the value and program gets completed over here. A very short and simple program is there. This algorithm will insert our new element into the queue. Same algorithm is over there, just a difference is over here. Instead of increasing front by 1, suppose we are increasing the rear value by 1, the operation which performs into the queue is called as an operation of delete. And the previous operation which we have discussed is an operation of inserting the value. So this is the difference between insert and delete. Just a one difference. Increase front by 1, it insert the value. Increase rear by 1, it decrease the value. Now let's convert this particular thing into the programmatical view. So for that I have written one sample code. Let's first test that particular code and then we'll see over the notepad for better visibility. So let me open that code first. This is the code. Let's check. As there are no syntactical errors, let's execute the same thing. There is an option 1, 2, 3 and 4. One is for inserting the value in a queue, second is deleting the value in a queue, third is the displaying the value in a queue, and fourth is exiting the value from the queue. So I am selecting operation number 1 as I am executing this particular program for the first time. So first value which I want to insert is 3. Then second value which I want to insert is 7. Remember that first is 3, then 7, then 9, and then suppose 0. So this is the queue 3, 7, 9 and 0. Now suppose I perform the delete operation, then as per the theoretical knowledge of Q, 3 is going to be removed from the given list. If it is a stack, then 0 is going to be removed from the list. But right now we are discussing about the queue. So as per the theoretical discussion, 3 is going to be removed. So let's perform the operation number 2, that is called as delete. So I am selecting second operation. It shows the message that element deleted is 3. Suppose I am printing the rest part of the queue, it only displays 7, 9 and 0. So this operation successfully performs, this program successfully get executed. Again I wish to perform an insert operation. Now again I want to perform the delete operation. What happens if I delete a value, or we can say what happen if I select the delete operation from this particular program? Yes, 7 is going to be deleted. Let's see whether it works or not. Yes, it is working. 7 is deleted from the list. Let's print the remaining list. 9 and 0 is there. Now what happen if I select operation number 1? Operation number 1 is for inserting the value. Suppose here I am inserting the value called 10. Where it is going to be inserted? Yes, it is going to be inserted after 0. So let's check whether it is inserted or not. Yes, it is inserted after 10. So successfully the operation of Q for inserting and deleting the value is working. And suppose I press the operation number 4, program will be terminated. So I hope all of you are clear with the operation which has been performed by the Q. Now let's see this particular program into the notepad for better visibility. So I am opening the code in notepad. ત્યાં સુધી થોડુંક પાણી પી લેવાય, બહુ દેકારા કરી લીધા. Okay, let's continue. What you can see in the program, first there is a declaration of two necessary library function, that is standard input output.h and console input output.h. Then I have defined the size called 5. Then there are three components which I have declared, that is front as -1. I will tell you why I have written -1. Rear is equals to -1. Q of the size for storing the elements, that means ultimately what it does, Q of 5, maximum 5 elements I can store into the Q, as I am using array into this particular concept. You can go for the pointer also, but this is very difficult to implement the elementary data structure concept using pointers, so I used array over there, but this is not a rule. Then I have declared the three function, that is function of insert, function of delete, function of displaying the value, and this UDF are the type called function without argument, without return value. Then into the void main statement, here I have designed the menu, which menu repeats till I have not selected the operation number 4. So after CLR SCR, there is a printf statement which prints our menu onto the screen, contains the 4 different operation. Operation number 1 is insert, operation number 2 is delete, third is print, and fourth is exit. Then there is a option of accepting the choice of user. As per the choice of user, switch statement transfers the control into the proper sequence of selecting the case. That means suppose here I select option number 1, case number 1 will be executed. If I select option number 2, case number 2 will be executed, 3, 4 and so on. Now suppose over here I have selected operation number 1, case number 1 will be selected. Inside the case number 1, 2 UDF I have called. The first one is insert and second one is for displaying the value. So as the function call is done, program transfers the control over here. So this is the practical implementation of insert operation for Q. In this UDF there is a number which is called as element, which we have insert into the queue. So there is a message, enter the number. Whatever the number I enter stores inside the array, store inside the variable called number. Suppose first number I have inserted is 5. Then whenever I have inserted 5, it checks one condition. That condition checks rear is less than the size of 1. What is the value of rear that I have set? -1. -1 is less than the size of 1, less than the size of -1. What is the size of 1? Size is 5. 5 minus 1 is 4. -1 is less than 4. This condition becomes true. કેમ કે -1 છે એ 4 કરતા લેસ છે, એટલે આ condition true થશે. As the condition becomes true, it increase the value of rear by 1 and set on the first location of array. Even we can start deleting the first element also. Means in a queue, if there is a first element which we have inserted, the first element which we want to delete, even it should be possible. That's why I am setting the value of rear at the first position. What happens if I do plus rear over here? Rear is -1. -1 plus 1 means 0. And what is the first location of array? 0. So rear is going to be set at a first location. On that first location, whatever the number I have entered is going to be stored. Even at that particular time, one more condition will be checked. If front is equals to -1, yes, initially for 5, value of front is -1, so it increased the value of front by 1 also. That means the 5 is going to be added into the queue. As the program repeats, suppose I am selecting an insert operation again. Then suppose I am inserting another value called 0. What happens? This condition becomes true. Rear increased by 1. Front is not going to be increased, and the new value is going to be stored inside the queue. Same like that, this operation repeats for n number of values. Say for example 5 values I have inserted into the queue. Ultimately what happens? After storing the 5th value, this condition becomes false, and what it shows, queue is overflow. Same operation over here I have mentioned for delete. Suppose I have started deleting the deleting the element from the queue. That means suppose I have selected operation number 2. Operation number 2 selects case number 2. Case number 2 is for deleting the elements. Whenever I delete the elements, as per the logic, 5 is going to be deleted. So for deleting the elements, first it will check that whether the value of front is equals to -1, then it shows what? Q underflow. But in our case, front is already set to the +1, so this condition becomes false. As the condition becomes false, it displays the element, the first element of the queue, which is going to be delete. Parallelly, it will check that whether the front and rear became same. Ultimately, at this particular time, it set the value of front and rear is equals to -1. Why? This is over there. Say for example, one by one I am deleting the values. The element of Q works for deleting the values from the queue is rear, as per our logic. In this program, I have used rear for adding the value and front for deleting the value, but you can use either or. There is one mistake into the theory, let's correct it. As this particular program is concerned, for adding the values, we have to use rear, and for deleting the value, we have to use front. Just make a simple change over there, so there would not be the confusion. Say for example, every value is deleted from this particular queue. So at one point, front and rear becomes same. So whenever the front and rear became set, we need to set it again back to the -1, because queue is empty till it not becomes true. That means till this particular condition becomes not true, it increased the front by 1, which deletes the operation. Again I am correcting my theoretical words. As far as this particular program is concerned, for inserting the value, we are using a component called rear. For deleting the value, we are using the component called front. In previous theory, I have says a reverse of this. That means for inserting we'll use front, and for deleting we'll use rear. But as far as this particular program is concerned, the thing is inverse. For inserting the value, we are going to use rear, and for deleting the value, we are going to use front. Sorry for that. Now, as per the sequence of program, third is the displaying the value, which is very simple. Over there, one variable is declared called I. Then there is a condition: if front is -1, it displays that queue is empty, nothing is to display. But if this condition is false, then one for loop repeats from the front to rear, and it display all the element of a particular queue onto the screen. That means all the remaining components, elements which stores inside the array is going to be displayed by this particular printf statement. So in this way, we can implement the simple queue. Just note down the definition of this particular program, that is, write a program to implement simple Q, and write down this program. Just pause the video and note down the selected line of code. Again I am repeating, just pause the video and write down this selected line of code. Then again pause the video and write down this selected line of code. Again pause the video and write down the remaining line of code. Again pause the video and write down the remaining line of code. I hope all of you have written the code successfully. I try my level best to explain all this very difficult concept of data structure in virtual mode. I hope all of you get the basic idea about the queue as far as the theory and program is concerned. In our next lecture, we will go for circular queue and their operation. Till that, thank you very much students for listening me, and have a nice day.